Deep in the deserts of the American Southwest lives a creature with a dangerous bite that could kill a human. The Gila monster. Its venom can cause intense pain, dizziness, and even paralysis. But hidden inside that venom lies something miraculous. A compound that would one day help millions of people control diabetes and even lose weight. We uncovered how one of the world's few venomous lizards became the unlikely foundation for blockbuster drugs like Ozempic, Wegovy, and Byetta, and how deadly venoms from snakes, scorpions, and even sea creatures are saving lives in ways science could never have predicted. In the late 1990s, endocrinologist Dr. Daniel Drucker from the University of Toronto was searching for a way to mimic a human hormone called GLP-1, or glucagon-like peptide 1. This hormone helped regulate blood sugar levels and controls appetite. But there was one problem. In humans, GLP-1 breaks down in the body far too quickly to be useful as a treatment. That's when Drucker's team came across the research of Dr. John Eng and Dr. Jean-Pierre Rothman, who were studying unusual molecules in Gila monster venom that affected the pancreas. This odd line of inquiry was driven purely by scientific curiosity. Why can a Gila monster eat as low as 3 times per year? From a Gila monster's venom, they isolated a hormone called Exenatide, almost identical to human GLP-1, but with one key difference. It didn't degrade quickly. It stayed active for hours, even days. This was the scientific breakthrough they were looking for. In 2005, a synthetic version called Exenatide became the world's first GLP-1-based drug, approved by the FDA and sold under the name Byetta. So, how do drugs like Ozempic, Wegovy, or Mounjaro actually work inside your body? These medications mimic the effects of GLP-1, the same hormone inspired by the Gila monster's venom. When injected, they stimulate the pancreas to release insulin after meals, lowering blood sugar. Slow down gastric emptying, meaning food stays in your stomach longer. And most importantly, they send powerful signals to the brain that reduce hunger and cravings. Over time, people taking GLP-1 agonists eat less, burn stored fat, and experience significant weight loss. That's why drugs like Ozempic and Wegovy have become so famous, not only for treating type 2 diabetes, but also for helping with obesity and metabolic disorders. But behind this global health revolution is a venomous reptile that most people have never even heard of. The Gila monster is native to the deserts of Arizona, New Mexico, and northern Mexico. It's slow-moving, solitary, and spends most of its life underground. It can consume a large amount of food, sometimes up to a third of their body weight in a single fitting. This large intake allows it to store fat in its tails and abdomen for lean times, such as during the winter or hot, dry summers. Its diet consists of eggs, birds, lizards, tortoises, newborn or young mammals, like rabbits and pack rats, nestling birds, and other small animals. Gila monster bite delivers a potent mix of toxins designed to immobilize prey, but it doesn't use it for hunting. It's a defensive weapon. Within that venom, researchers found Exenatide, the molecule that mimics GLP-1 so closely that it can regulate human metabolism. Nature, it seems, had been running this experiment for millions of years, and we were only just catching up. Currently, more than 2 million people worldwide take Exenatide or its successors, the descendants of this desert lizard's biochemical legacy. The Gila monster isn't alone. All across the animal kingdom, deadly toxins have been turned into life-saving medicines. The Brazilian pit viper, for example. Its venom led to the development of lisinopril, one of the world's most prescribed blood pressure medications. The same venom that once killed prey now helps millions manage heart disease and hypertension. Or consider the Caribbean sea sponge, Tectitethia crypta. It produces rare nucleosides molecules that inspired cytarabine, a chemotherapy drug that fights leukemia and lymphoma. and is on the World Health Organization's list of essential medicines. And then there's the death stopper scorpion. Its venom contains chlorotoxin, a peptide that binds only to brain tumor cells. In 2004, oncologist Jim Olsen used it to create tozolarostide, a fluorescent dye that lights up cancerous tissue during surgery, allowing doctors to remove tumors with unprecedented precision. From killing to healing, nature's chemistry is far more complex and complete than we can imagine. These breakthroughs reveal a deeper truth. Mother Nature is perfect, provides us with everything we need, and it's a living pharmacy. Each species, each toxin, could hold the key to curing diseases we haven't even discovered yet. The problem is, many of these creatures are endangered. As ecosystems collapse, so do our chances of finding the next life-saving compound. Protecting biodiversity, it is not only an ethical choice, it's a medical necessity too. Somewhere out there, the cure for Alzheimer's, cancer, or even aging itself might be hiding in the venom of a snake, the sting of a jellyfish, or the bark of a tree. The Gila monster's bite once symbolized danger. Today, it symbolizes hope, proof that even the deadliest parts of nature can heal us. What other miracles could be waiting in the wild? Let us know your theories in the comments, and don't forget to like, subscribe, and turn on notifications for more incredible stories of science and discovery.